Hi, my name is Brian Lutman. I'm the product line manager for excitation systems here at Basler Electric. And today we're going to talk uh, a very high level about Basler Electric, what we do, who we are. We're going to touch on the company, and then we're going to look at some pictures of applications where our products are used. We're going to talk about the products that were used in that application and any interesting aspects of those applications. I've been with the company for about 20 years now. I came right out of school and went into field service. So I actually traveled around the US, Canada, Mexico, visited some other countries as well, actually commissioning our products that work specifically with voltage regulators and excitation systems. Our core purpose as a company is to enhance people's lives, and we do this by developing very reliable solutions, innovation, and high performance of executing. Those are our core values. Core values include integrity, reliability, conduct, and sustainability. Our success depends on everybody here working together with integrity and initiative and a can-do attitude to making our products work for your system. So it is who we are, and we strive to achieve these values. The company got started in 1942 by Carl Basler. Carl started the company in Highland, Illinois, again, 1942. So we've been in business a long time. Our initial products were transformers, magnetic coils, reactors, and other magnetic components. The way we got started, as I understand it, is there was an opportunity to rework a number of transformers that had been damaged. So Carl took them into a shop, reworked them, tested them, and then resold them. And that's how we got started. So Carl was in charge for a number of years. He was succeeded by his son, William, or Bill, as we know him, Bill Basler. So Bill is still on the board. We see Bill come in every once in a while and walk around and take a look at what's going on in the factory. But really, Greg Basler, his son, is the chief executive officer of the company and the vice chairman of the board. So Greg is in the office just about every day. He's very involved in the company. So this is the third generation of family leadership here at Basler Electric. Our products are everywhere. We've got products in 145 countries that we know of. There's probably a few others out there that have our products that we're not aware of. But you've got a very, very large footprint. Again, we've been in business over 80 years. 25% of the Fortune 100 companies use our products. We can directly point to 340 gigawatts of generation controlled by Basler Electric equipment. In the US, 70%, well, more than 70% of the top US power companies use our equipment. And again, we're in over 145 different countries. We have 5 facilities where our products are both built and sold out of. In the United States here, our corporate headquarters is in Highland, Illinois. This is where I'm based. This is where Kate is based. This is where all of our engineering, all of our product engineering is based. I actually sit right over here. I don't know if you can see my mouse. I know you guys care about that. But as a company here, we've got a fairly large factory, and we do all of our custom excitation equipment here. We build protective relays here. We build voltage regulators here. Our Taylor, Texas facility over here on the left, this is where we do more of our high volume products. So this would be our DGC 2020 controllers, the 2020 HD, some protective relays. So just, more higher volume stuff. So, tens of thousands of units per year as opposed to single digit or hundreds of units per year in Highland here. We have our field service and troubleshooting and commissioning, and our services group, that was the word I'm looking for. Our services group is based in Littleton, Colorado. They go by Basler Services. So they're, a wholly owned subsidiary of Basler Electric. They do a lot of turnkey work. So if you have need of generator modeling, or if you need a new excitation system, they can come in, evaluate what you need, get equipment from Basler Electric, and then they can install it, commission it, and even do annual maintenance and annual testing. So that's the group out in Littleton, Colorado. We'll talk about this more, but part of Basler Electric, we build a lot of Class 2 transformers. Class 2 transformers are the transformers that you can hold in the palm of your hand. These are used in a variety of industries, very large in the HVAC equipment. I had a water softener that used a Basler Electric transformer. We build these by the millions, and they go in a bunch of appliances, vending machines, beverage dispensers, all kinds of things that you're never going to see. But that's a large part of our business, and those are made primarily in Piedras Negras, Mexico. We do build some of our larger transformers, like the 1 and 2 MVA transformers for excitation. Those are actually built in Highland. So we build magnetics in both places. We do have an office in Suzhou, China. This is a sales office primarily. So they take our products and sell them to the local market there in China. So there's about a dozen folks there. They also do a lot of our troubleshooting and commissioning in China as well. So we've got 5 facilities, all do different things, but again, all of the design work is done at a corporate headquarters here in Highland, Illinois. 3 of our facilities are ISO 9001 certified. Those are our corporate headquarters in Highland, our manufacturing in Taylor, Texas, and then our office in Suzhou, China. When we build a product, it's tested multiple times. Since we are very vertically integrated, we will test the bare circuit boards. We'll populate and test the bare circuit boards. Then we'll test the unit as a whole after all the circuit boards have been inserted and assembled. And then we'll test the equipment if it's going into a system. So if you buy a DEX 250 from us in a system, it'll be tested at least 3 times before it leaves the factory. All of our design has design verification testing associated with it. So when you buy a product from us, you can rest assured that we've done the full suite of tests. We do electromagnetic compatibility testing. Most of our products have some level of agency recognition. They've got very wide temperature ranges, very high shock and vibration ranges. Most of our products are subjected to a HALT testing, so highly accelerated life testing during development. This is where we put the product in a chamber that shocks, or that provides vibration and shock for a number of hours while temperature is being cycled from minus 100 Celsius all the way up to plus 100 Celsius. So it's a very, very stressful test. We do that to identify where there are weaknesses and to figure out where we can make improvements. We also do humidity testing and salt fog testing. A lot of our work is custom, especially when we talk about our large excitation systems. So we can even do customer specific testing. Sometimes customers want to do a heat run or something like that. All right, so a high level products and services we offer. I'm part of the Power Systems group of Power Systems products. So we've got protective relays, excitation systems, voltage regulators, and then genset controllers. We design and write our own software. The software is what's used to configure and commission the equipment. We even have software now that you can use for looking at data logs. Best Data is the new software. I encourage you all to find that on our website and take a look. It's very, very cool piece of software, and it replaces our BestWave software. Both of those are free. BestWave came out in the late 90s and was a way to look at waveforms, and Best Data is a modern take on that. All right, custom transformers. We talked about Class 2 transformers. So again, those are typically going to large OEMs for use in appliances, vending machines, and whatnot. But and they're all custom. So we will typically have a OEM come to us and say, hey, I need a transformer that can support this VA with this input voltage and this output, and then we'll design it to meet their specific needs. We also do large transformers, again, for our excitation systems. I think we go up to 2.8 MVA. These are drive type transformers that are wound in Highland. We'll even do custom engineered products. So if you are a genset OEM who has thousands of units you sell a year, talk to us. We can talk about private labeling, either a custom overlay or even a fully custom product. Really depends on what you're looking for. Our engineering services are pretty much driven by our group in Colorado, so Basler Services. And again, they can do just about anything. Really, their primary role is for turnkey installation, commissioning, but they'll also do modeling studies, troubleshooting, whatever you need. If you just have questions about products, how do I set the limiter on the DEX 250? You can always reach out to our technical support group here. We're available 24/7. And something new that we're starting, and this presentation is part of it, is Basler University. So Basler University is going to be a combination of items. It's going to be a series of webinars like this one. We're going to have classes that are available for you to watch on demand. We can develop custom training for your needs. So if you've got a group of technicians that wants to be more fluent in Basler products or a specific Basler product, reach out to us, let us know, and we can set that up. So just a little history here on Basler Electric. We covered some of it, but Basler was founded in 1942. We've been doing voltage regulators since 1959. We started manufacturing the small class 2 transformers in 63. My product line, excitation systems, we got started with that in 1965. In 1969, we introduced our first solid state protective relay. And I say our first solid state protective relay, but it was actually the first solid state protective relay on the market. Relays before this were electromechanical in nature. So we were very much an early pioneer in protective relays. We introduced the first protective relay that had a microprocessor, at least in the US, in the 80s. Digital regulator was in 1991. In 2006, we actually acquired one of our largest competitors in the excitation line. So we acquired the ECS 2100 product line. So now we have got the capability of building excitation systems that can put out up to 10,000 amps of current. In 2017, we acquired E Squared Power Systems. That has turned into Basler Services in 2021. In 2021, we also acquired another company called Segrity, and they do a lot of work with hydro governor systems. So it was a really great synergy to bring Segrity online so we can do excitation systems and governors. All right, so let's get into, I'm going to say, the fun part. We're going to be talking today specifically about our DGC family of products in the genset world. We're going to talk about our DEX family of voltage regulators and excitation systems. And we're also going to talk about the AVC family of voltage regulators. And then, of course, we're going to talk about protective relays, specifically the ES family of relays, and the BE1 family. The Flex is by far our most exciting relay that we offer. If you haven't seen the Flex, I very much encourage you to go to our website and read about it. It's really cool. It's got changeable card slots in the back, so you can configure it to be exactly what you need. We've got a nice 7-inch touchscreen on the front, so you really have a modern look and feel, similar to your cell phone. It's a really cool product. Before we dig too far in, let's just level set here. How do you make electricity? You probably learned in high school or college that if you have a rotating magnetic field and a stationary conductor, you'll have electricity flow. Electrons will start moving around and you'll get electricity. A voltage regulator and an excitation system, we control the strength of a magnetic field that's rotating around inside of a generator, and we're able to use this to control the output of the machine. If you were ever in fourth grade and you had the opportunity to make an electromagnet with some wire and a battery, and you picked up some paper clips, conceptually it's the same thing. We're using a magnet that we're controlling with electricity to spin around and control the output of a large generator. Controlling the output of the generator with a magnet is only part of the story. There is a prime mover that is actually spinning the generator. This is where the real power that's doing the work comes from. The prime mover is typically a hydro turbine, a steam turbine, something like that. Or an internal combustion engine, that's another large one. In North America, they all rotate at the same synchronous 60 hertz frequency. Other parts of the world is 50 hertz. We're not going to go into the details of why, but just 60 hertz is what it is here. And then just one other concept I want you to be aware of is, everything's spinning at the same frequency. So how do you get power out of a machine? This is a concept that's a little hard to grasp. But conceptually, your machine that's putting out power is pushing harder. It's pushing against the grid. So it may be trying to get the grid to go to 60.01 hertz. And when it does that, that's where power gets sent out of the machine. The analogy is setting the cruise control on your car. If you're going on a flat strip of highway, your engine is going to be using a pretty constant amount of fuel. But as soon as you start going uphill, the car's computer will say, hey, I need more gas. So more gas will go into the engine. You'll still maintain your same speed, but going uphill requires more fuel. So again, conceptually, that's what the generators are doing. They're pushing harder against the grid to send out power. This is an example of a generator set, or gen set as we'd call it. This is a pretty typical large gen set. This machine, eyeballing it, I think it's about 2 MVA. And what I like about this is we've got some good examples of our product. Here we've got a DEX 250 right here, and this is a DGC 2020 top mount box. We're going to talk about where this gets used later, but when you think of genset, think of this. Again, this is about a 2 MVA machine. You can see there's a guy here. You get a real sense of scale. So that's what I would consider a relatively small machine. What we're looking at here is an example of a steam turbine. Steam turbines are considerably larger. So we just looked at an internal combustion engine that was about 2 megawatts. This steam turbine, if I remember right, is about 500 or 600 megawatts. Yeah, don't hold me to the details, but hundreds of megawatts right here. And what we see on this end, this is where the steam comes in. The steam goes through a first turbine stage and goes through a second turbine stage. And then that energy spins the generator. So the generator is this cylinder over here. The excitation system, or the power to the magnet that's spinning around, is in this little house over here on the left. Okay, so now let's talk about actual applications here. So power generation is a primary place where Basler Electric is involved. Specifically utility or private power producers, but big machines that are contributing large amounts of energy to the grid. This picture here, this is an example of a relatively small hydro in I think the southern US, if I remember right. This is one of the plants I went to on my field service travels. A plant like this could use DEX 250s or DEX 250Es. It really depends on how much excitation current is needed at this by the generator. This plant was interesting because I think, if I remember correctly, I think now it's about 115 years old. So that's really one of the fascinating things about hydro plants. Most of them were built in the 30s, 40s, and they're still, or even earlier, and they're still running. This plant actually used heartwood bearings. So actual wooden bearings were used to keep the shaft in place. So it's just a fascinating place to take a look at. But something like this, these turbines, I think were on the order of 5 megawatts apiece. There were 3 of them. They could get along with a DEX 250E or a DEX 250. We also have equipment at large hydro power plants. This plant is again in the southeast in the Appalachian range. This plant is interesting because it has 5 machines. These machines range from, I think it was 50 to 90 megawatts. And one of the remarkable things about this plant is it's a pump storage facility. So 3 of the machines actually can pump water uphill. It uses DEX 400s, started with DEX 300s, and then we have upgraded it to DEX 400s, and now I believe it has some DEX 450s on site. So on the left here, this is an example of, got the DEX 450, but a plant like this could also use DEX 2100s. Again, the DEX 2100 can go up to 10,000 amps, where our DEX 450 products top out at about 2,500 amps. Going into work in the morning at this plant was kind of interesting because the river was flowing the wrong way because they were actively pumping. And the concept of a pump storage is during the day, especially today, during the day with all of the wind and solar that is going to be generating power, the cost of electricity is pretty low. So a plant like this will be able to use that low cost energy to pump water uphill and store it for when electricity is expensive or when electricity is needed. So pump storage hydros think of them as a large battery that can be used on demand. Another great thing about hydros is they're able to go from 0 to 100% output in a very short amount of time. This plant, I think it was on the order of 20 seconds. It could go from a full stop to full output. So it was very impressive. Natural gas power plants are, again, the bread and butter of where our products are used. There's a few different flavors of natural gas power plants. What we're looking at here are some combustion turbines. Inside of here, we've got air intake, then there's a turbine generator, and then you've got exhaust going out the top. These plants, if I recall, are interesting because they're in tandem. These plants actually have 2 turbines that are connected to a single shaft that are connected to a single generator. So they're able to have some variability in their output if they need, but they're also able to come online very quickly. That's one of the advantages of natural gas combustion turbines. So a plant like this one I think specifically used our DEX 15, but today it could use our DEX 250s. The larger ones, combustion turbines go up to 200-ish megawatts these days. Those larger units could certainly use a DEX 450 type of excitation system. If I'm remembering correctly, these were on the order of, one dual unit was on the order of 20 megawatts of output. These combustion turbines are frequently referred to as peaker plants, with the idea that they're brought online when the grid needs additional energy. They can be a little more expensive to run, but if you need power, you need power. Coal plants are a traditional user of our products, although in the US today there are fewer and fewer coal plants. The coal plant you're looking at here has actually been decommissioned and completely removed, and they're contemplating putting a 400 megawatt battery bank in its place. But yeah, coal plants were a huge user. Most of the coal plants went in the late 70s and early 80s. There was a big push. So in the 2000s, they were all ready to have their controls upgraded. Updated controls would allow them to meet NERC requirements, give them capabilities like data logging that they wouldn't have had with analog systems, and just overall be higher performant. The controls upgrades sometimes also went along with pollution control upgrades. They'd say, we're going to upgrade this unit so it can run for another 30 years. So if you look at the plant itself, down around the base, you can see there's a lot more stuff on the right side than there is on the left side. These units on the left have actually been decommissioned, and the units on the right were upgraded with additional pollution controls. So that's what we're seeing there. We also have equipment at nuclear power plants. When we acquired the Cutler Hammer line of excitation systems, they had a number of excitation systems on the main units at nuclear power plants. But Basler has had a long history of working with nuclear power. Our first excitation systems were for the emergency backup generators at nuclear power plants. So at one point, we were on something like 60% of the nuclear power plants in the US. I don't know what that number is today, but as nuclear power plants are going through relicensing to stay connected to the grid, we're seeing demand for safety-related equipment, which would be our vintage voltage regulators and excitation systems. So we're actually resurrecting designs from the 50s and 60s to be used at nuclear power plants today. So that's a very active area for us. All right, so moving on to industrial uses of our equipment. One of the more fascinating places I had an opportunity to visit on my travels was a plate glass factory. And what you're looking at here, you've got a bunch of bins back here of various sands and clays. Those all get mixed together and put in a big pot and melted. This pot looks kind of like a bathtub with one side that's a little lower than the rest. And depending on the plant, they'll either use electricity to heat the sand to make it molten, or they'll use natural gas. But if they're using natural gas, they're using motors and compressors. So keeping the electricity on is absolutely critical for plants like this. The last thing you want to do is have a big giant bathtub full of molten glass. So this plant had a couple of backup generators with our products on it, and they would make sure that electricity never went out so that they could maintain a nice constant output of glass. And the way the glass is made is there's a fine amount that comes out of this bathtub, and it slowly cools over the course of a quarter-mile track, right? So this is one long continuous conveyor belt where the glass comes out and is cooled, and then they'll change the speed of the conveyor belt to change the thickness of the glass. Anyway, it was a fascinating place to go to, and it was real emblematic of why having backup power is critical for industrial facilities. Another fascinating place I went to was an air separation liquefaction plant in the middle of nowhere, Montana. This plant brought in the pure, clean Montana air, chilled it to sub-zero temperatures to turn it into a liquid, and then expanded it out and separated the different chemicals. So then they would have a tank of nitrogen, tank of oxygen, and tank of argon. And conceptually, this works just like your refrigerator or freezer at home. You've got a compressor, you've got the refrigeration cycle with phase change materials and whatnot. But what we're looking at here on the end, that is, I think it was about a 3 megawatt motor that drove the compressor. So again, this was just a giant freezer. And something like this used X250. Nitrogen's typically used anywhere where you need an inert gas. The classic example is a bag of potato chips. If you open a bag of potato chips, that's not air in there. That's nitrogen gas. That prevents the oils in the potato chips from becoming rancid and preserves shelf life. And then argon and oxygen. Oxygen obviously used in hospitals or for anywhere you need to breathe. Then argon's used a lot in welding applications. It used to be used in neon tubes. That's not so much anymore. But anyway, it was fascinating to see this whole process and know that our equipment was a part of it. Lumber and paper mills are another place where our products are used. It may not be a very obvious application for our products, but both a lumber mill and a paper mill, they both use steam in their process to break the wood down to the end use case. They've got plenty of material to burn, bark and wood chips that aren't used in the process that gets burnt, and creates steam, powers a turbine, and creates electricity. So it's a very large use case of our products. I think the plant on the right was in the Upper Peninsula of Michigan, and I think the one on the left was out in the Pacific Northwest. Kind of another interesting application of our products is, this looks like an internal combustion engine, and it is, but what's fascinating is this uses natural gas as the power source, which again is not too unique these days, but it's actually coming from a landfill. This 9 megawatt plant, I think this is a 3 megawatt machine, there's 3 of them here. This was literally on the side of a landfill. So the landfill out in California captures the decaying methane. They've got a whole series of pipes and tubes around the landfill. So as garbage decays and generates this combustible gas, the gas is captured and then run through the engine to create power. So this offsets their need for their water treatment plant, offices, and this may seem like a lot of energy that they're capturing from a landfill, and it is, again, 9 megawatts. But up the hill away from this, they actually had a 50 megawatt natural gas turbine that was also powered from landfill gas. So this was just the gas that was in excess of what they could use on the turbine. And again, our products are critical to control the voltage coming out of this, synchronizing these machines and making sure that the generator behaves as needed. Oil and gas is a huge business for us. We're used both in onshore drilling, so out in West Texas or North Dakota. There's a real need for power at these remote sites. But one of the most remote sites you can have is an offshore oil platform. These platforms typically have tens of megawatts of generation on board, either using gas from where they're drilling, or they'll have large tanks of diesel on board. And some of them are close enough to shore where they'll have some sort of fuel connection. But a platform like this could have 2 or 3 or 4 DEX 250s on it, and then associated protective relays. And this platform will run as a little islanded power grid on its own. The generators could have DGCs on them to do real power sharing, or come on when needed. DEX 250s would control the generators, and you could have B111s or B1 flexes to protect the entire system. Chemical plants also use our equipment. Chemical plants, again, use steam in many of their processes. So if there's steam, you can always run that steam through a turbine and generate electricity. What we're looking at here is, I think this is a refinery just north of St. Louis. Depending on the amount of steam available and the configuration, they could be using a DEX 450 system, a DEX 250 system, or they might not even be using our products to generate power. They may be using our products to control synchronous motors. Now, synchronous motors are very, very similar to a synchronous generator. The big difference is the flow of power. A synchronous generator, we'll say, creates power, and a synchronous motor absorbs power. But DEX 250s and 450s are used very commonly to control synchronous motors. Agriculture is a place you may not have considered for uses of our products, but backup generators for livestock, that's a very, very critical application. Livestock is very similar to you and I. They both have a temperature range where they're happy, and it's very important to keep them in that temperature range. So these livestock facilities will have emergency backup generators for if the power goes out, and they will frequently have our DGCs. They'll have our voltage regulators. What we're seeing here on the left is a DEX 150, but they may not need as sophisticated of a product as the DEX 150, and they may be able to use an AVC analog voltage regulator. It really depends on the size of the system and the needs of the customer. A chicken farm, there's a classic Basler story with the chicken farm, where our product was there for years and years, and there was some misoperation with it. So when it was sent in and we looked at it, the circuit board was completely covered with nasty chicken stuff. And ever since then, we've been very cognizant of the need of adding potting material to our products. So the DGCs, the DEX 150, the AVCs, they're all potted. So they can go into these very nasty environments and run successfully and reliably for years and years and years. Our DGC 2020s can also control engines. There's no reason that they have to be paying attention to a generator. So we have a specific product called the IEM 2020 that is an industrial engine controller. So it pays attention to the speed of the engine, the lubrication, startup process. It pays attention to the engine. So it's kind of a stripped down version of our genset controller. But these are used in industrial pumps. It's a very common application. And what we're seeing here in the photo here is a engine controlling a pump with IEM on it. And this is a mobile one, so it goes wherever it needs to go. Speaking of pumps, another application of our products are water pumping stations. This is a picture of one of the pumping stations in California. California has a large aqueduct system that brings water from one part of the state to the other. A large part of California's industry is agriculture. There's a lot of farming in the Central Valley of California. And there's a lot of people in places like Los Angeles that need water. So being able to move water across the state is critically important. So they have this aqueduct system. And what you're seeing here on the bottom is a large pumping station. If I remember right, this station has on the order of 15 3-megawatt motors, and they're controlled by a combination of DEX 450s and DEX 250Es. Again, these are synchronous motors that we're able to control. And all this station does is pumps water uphill. And there's a series of these stations throughout California, and our products are used in many of them. All right, let's talk about commercial applications of our products a little bit. I'm showing this genset picture again because most of what we're going to be talking about in the commercial space is emergency backup power. That's just kind of the nature of it. We've got a couple more products on here that I don't think we had last time. We've got our ES line of relays. This is an industrial relay that's great for this type of application. And again, we've got our DEX 150, our DEX 250, B111 protective relay, our DGC 2020 HD, and then our AVC voltage regulator. Kind of the classic and stereotypical place you need emergency backup power is at a hospital. This is a hospital near where I live, and they've got a genset around back that has our equipment on it. That actually has a DGC 2020 on it. But if the power goes out, you need to keep all the equipment online at a hospital. So it's very critical to have backup power there. Rail and transit. This is an area where we have some products. It's not huge for us, but we've got a couple applications that are interesting and worth talking about. We've got a picture of a locomotive here on the right. The way locomotives work today is they use a generator. That generator creates electricity, and that electricity drives electric motors, which drive the wheels. So the engine itself is not directly coupled to the wheels at all. There's a lot of efficiency advantages here. You also have the advantage of being able to achieve higher torques. But if you've got a motor, and some of these are synchronous motors that they'll change the speed, if you have a synchronous motor, you can use one of our voltage regulators. So there are a handful of locomotives out there that are using DEX 150s. And I think there's even a couple that use DEX 250s. So that's very, very unique application. The other unique application of our products is in the light rail. Light rail systems are typically DC, and there is not a lot of relays out there that can measure high voltage DC and operate on it. So our B111M, in combination with our ITD, or isolation transducer for DC, we're able to monitor what's going on and provide protection. So that is a kind of a different application that maybe you haven't considered. Early on, well, I'd say in the 80s, we did a lot of stuff in the military that also branched out into other areas of transport. Here we've got a ground power cart. This is how you keep the lights on in an airplane when it's sitting at the terminal without the engine spinning. So these ground power carts have a little generator inside. But what's unique about this generator, instead of putting out 50 or 60 hertz like is typical around the world, it puts out 400 hertz. The higher the frequency is, the smaller the magnetics need to be. So in an airplane where weight is critical, having small transformers is also critical. Minimizing that size minimizes weight, which means you can carry more people or go further. So these ground power carts are started up and brought up to jets that are waiting to take off. So next time you're in an airplane, take a look and see if there's a ground power cart nearby. Mobile power, another big area for us, specifically our genset products and voltage regulator products. Here there's a couple examples of some towable gensets. The one on the left, I think, is about a 256 kilowatt unit. The one on the right is probably about 100 kilowatts. These are used anywhere where you need mobile power. I'm an electrical engineer that gets excited about these things. So every time there's a carnival or fair in my hometown, the first thing I do is I walk over to the generators and peek inside to see what genset controller they're using. It's quite exciting. I encourage you to do that, although don't tell anybody I told you to do that. It's just amazing how many places mobile power is used. And again, inside of here, you've got an engine coupled with a generator, and these are controlled by a genset controller that will turn everything on. And you can even get some pretty complicated schemes where the genset controller can do synchronizing and protection. Maritime is another big user of their products, specifically our voltage regulators. Voltage regulators are used more and more for not only house power for the ships, but also for primary propulsion. More and more ships are going from having a direct coupling from the big engine to using motors on the propellers. So you have either two separate electrical grids or one large electrical grid, but in either case, DEX 250s are very widely used. The two ships we're looking at here are in the NOAA fleet. The one on the left is the Atlantis. This ship is kind of neat. It carries around, I don't know if you can see it, but there's a little deep sea submersible here. This submersible has gone down to visit the Titanic, and it's been in use since the 70s. And they've got, I think, six of our DEX 200s on this ship. And then the ship on the left is a fisheries vessel. My little story with this one is they used DEX 250s, but this ship was meant to be very quiet as to not scare the fishes, which was great. But the consequence was that it wasn't very stable in the water. It rocked around a lot. So when we were out to sea trials and I was in the engine room, I didn't feel so good with the ship rocking around deep in the bowels. So it was a very memorable experience I don't want to repeat. But research ships aren't the only ships that use our products. They're used on some tanker ships. This is a natural gas tanker ship. The one that I was on had the ability, and I think it's pretty common, it would actually take some of the natural gas that it was transporting and use that to power the ship for propulsion, both propulsion and the electrical load. So it was actually able to use some of its cargo as its source. These ships have big generators on board, so voltage regulators like DEX 450 can be used, or even some of the smaller generators can use DEX 150s. We're on natural gas tanker ships, oil tanker ships. We're also on cruise ships. You may not really think about when you go on a cruise how the lights are staying on, but they've got tens of megawatts worth of generation on board to keep everybody air conditioned and happy. These ships use DEX 250s, DEX 150s. I use our older products as well. As a field service engineer, I missed out on the cruise ship trips, but my counterpart had an opportunity to go on 3 or 4 cruises to work on equipment, and he said they were very interesting trips to go on. Icebreakers, we've got a couple icebreakers in the US fleet that are using our equipment both for primary propulsion as well as keeping the lights on. DEX 250Es are used in those applications. Aircraft carriers as well. Aircraft carriers have large generators. We're not so much on the main units, but the emergency backup generators sprinkled throughout the ship use our products. Also, there's protective relays in some of these applications. Submarines, a handful of the US submarines use our products. We were very big in the military in the 80s, so we still support our government customers pretty regularly. Moving over into the world of telecommunications, data centers use tons of our equipment. Protective relays, voltage regulators, genset controllers. You have to remember a data center will have, 24 emergency gensets, give or take. And then there's usually on the order of 2, 4, 8, or 10 data centers at a specific location. And there are tons of data centers around the world. They've got a very large need for our products. Cell towers, it's another large one. If cell tower doesn't have power, we can't communicate. I think it's law in the US that all cell towers have some sort of emergency backup power source. So again, genset controllers and voltage regulators are widely used there. Talked about remote locations, a couple of the interesting locations that are very remote. On the left here, we've got a hydro plant in the Andes Mountains in South America somewhere. And on the right, we've got piles of sulfur that came out of the oil sands in North Alberta. And what I love about this picture, if you see that little spot right there, that's one of the giant dump trucks, the size of a house. So that really just kind of gives you a sense of scale of the operation there. So in the oil sands, they extract the oil, they do a little bit of refining to remove the sulfur, and then they put it in a pipe and send it down to the US. Anyway, it's incredible to see that. But it's a huge operation in the middle of nowhere. So they had, I think, about 300 megawatts of on-site generation to power all their operations. Another extreme environment is McMurdo Station in Antarctica. We had equipment there, and it ran great for years and years, and as far as I know, it's still there. But yeah, you don't get much more extreme than Antarctica. So that's all I've got. It was very high level. This is where our products are, and hopefully you got some new ideas on where you can use Basler products.